3I/ATLAS is finally here. Something just survived a journey no natural object should survive. For months, the whispers spread through observatories and research facilities worldwide. A visitor was approaching, not from the icy depths of our solar system's edge, but from the infinite darkness between stars. An object moving at impossible speeds, defying our models, changing colors like a chameleon, and exhibiting behaviors that made even the most skeptical scientists pause and wonder, what exactly is headed our way? 3I/ATLAS, the third confirmed interstellar intruder, and it just emerged from behind the sun alive. But survival was never guaranteed. At 68 kilometers per second, fast enough to cross the United States in 1 minute, this cosmic wanderer plunged toward our star, carrying secrets from alien star systems billions of years old. What we discovered in its wake has shattered assumptions, ignited fierce debates, and revealed something profoundly disturbing about the nature of interstellar space itself. The truth is stranger than any spacecraft theory, and far more terrifying. The first warning came when telescopes detected something impossible happening far beyond Earth's orbit. At 2.9 astronomical units from the sun, nearly 3 times farther than our planet, where temperatures plunged to -200 degrees and ice should remain frozen solid. 3I/ATLAS was hemorrhaging water into space, not trickling, not seeping, dumping it at 40 kilograms every single second. A fire hose at full blast sprang into the void. This wasn't supposed to happen. Comets don't behave this way at such distances. The physics don't allow it. Yet ultraviolet observations caught the unmistakable signature of hydroxyl radicals, water molecules ripped apart by solar radiation, forming a massive expanding cloud around the object. Something inside this visitor was violently active, impossibly early, and completely outside our experience. Scientists scrambled to explain the anomaly. Perhaps it was ejecting icy grains that melted independently, multiplying the surface area. Perhaps internal pressure was rupturing through weak points. Perhaps, but the models kept failing. Nothing in our cometary databases matched this behavior. 3I/ATLAS wasn't following the rules because it never learned them. It came from somewhere else entirely. Then came October, and everything went dark. Just as the object reached peak activity, just as instruments worldwide focused their full attention, just as we finally had the chance to study an interstellar visitor up close, the sun itself blocked our view. For 4 agonizing weeks, 3I/ATLAS disappeared behind our star during the most critical phase of its journey. Ground-based telescopes fell silent. The astronomical community held its breath. Some calculated the visitor wouldn't survive. Others feared we'd lost our only chance to understand what traveled across light years to reach us. But someone was still watching. Deep in space, a network of robotic sentinels maintained their vigil. Spacecraft designed to monitor solar storms pivoted their coronagraphs toward the vanishing comet. These machines, positioned away from Earth's perspective, scattered across the inner solar system, could see what we couldn't. They witnessed something extraordinary unfold in the solar inferno. The transformation was violent. As 3I/ATLAS dove toward perihelion, its brightness didn't just increase, it exploded. Astronomers measure brightness changes using exponential scaling, a power law relationship with solar distance. Before October, the visitor showed a respectable rate. Brightness scaling at ER to the power of -3.8. Standard cometary behavior. Inside 2 astronomical units, that relationship shattered. The new observations revealed brightness scaling at R to the power of -7.5, nearly double the previous rate. The object was shedding mass at velocities that defied every model of dirty snowball sublimation. It was as if something switched on, something woke up, and then it changed color. For months, observers on Earth saw 3I/ATLAS glowing dull red, the signature of dusty carbon-rich surfaces similar to the mysterious visitor before it, the cigar-shaped anomaly from 2017. Then it shifted to eerie green as cyanide compounds vaporized into its expanding coma. But the solar observatories witnessed the final transformation, deep, vivid blue. Blue light from a comet is rare. It's the fingerprint of specific molecular emissions. Carbon monoxide and amide radicals fluorescing under extreme ultraviolet bombardment. What the color shift revealed was terrifying in its implications. 3I/ATLAS was burning through protective layers, exposing its frozen core directly to stellar radiation. The dusty shield that had protected it for billions of years was gone. The true object, the ancient engine inside, finally revealed itself. But the solar observatories captured something else, something that sparked immediate controversy: a jet aimed directly at the sun. Comets develop tails pointing away from the sun, pushed back by solar wind and radiation pressure. Everyone knows this. It's textbook astronomy. So when images revealed a brilliant spike of material shooting from 3I/ATLAS toward our star, against the direction of solar wind, against the expected physics, the whispers began. Could this be a thruster, directional propulsion, evidence of artificial navigation? The images were undeniable. Composite exposures from observatories captured a distinct break in the comet's glowing envelope, a focused beam of gas and particles streaming sunward, as if something was firing, braking, steering. The geometry looked wrong for natural outgassing. The timing seemed too precise. And as the debate intensified online, a prominent voice entered the conversation with a shocking hypothesis. What if 3I/ATLAS wasn't a comet at all? The theory spread rapidly. The object exhibited non-gravitational acceleration. Its trajectory remained suspiciously straight despite the sun's immense gravity. The mass loss required to explain its brightness surge should have disintegrated any natural nucleus. Yet it remained intact, purposeful, seemingly controlled. Could we be watching an interstellar probe making a close approach to study our star? Was something intelligently navigating the darkness? The timing couldn't have been worse. Just as these questions reached fever pitch, just as analysis of the sunward jet intensified, 3I/ATLAS approached Mars, and the conspiracy deepened. The close encounter was scientifically invaluable. At just 28 million kilometers, the fleet of robotic explorers at Mars had unprecedented views. The most powerful camera ever sent to another planet, capable of resolving objects the size of furniture from orbit, aimed its lens at the approaching visitor. If anything could photograph the nucleus directly, expose any artificial structures, reveal the truth, this was the moment. Then came the government shutdown. For 6 excruciating weeks, as public interest peaked, as social media exploded with theories, as millions demanded answers, nothing. No images, no data. Complete silence from the space agency. The vacuum filled instantly with speculation. What did the high-resolution camera see? Why the delay? What was being hidden? When the images finally released, they showed nothing. A fuzzy, unresolved blob surrounded by 1,500 kilometers of gas and dust. No visible nucleus, no structures, no answers. Just a ghostly smudge where a clear photograph should have been. The timing felt too convenient, the silence too calculated. Forums erupted with accusations of cover-ups and suppressed evidence. But amid the conspiracy theories, something genuinely groundbreaking went almost unnoticed. The rovers on Mars's surface, machines designed to search for ancient microbial life in dried lake beds, turned their cameras skyward. In the resulting long-exposure images, 3I/ATLAS appeared as a faint streak among alien stars. The photographs were blurry, barely visible, scientifically modest. But they represented a cosmic first, humanity's first image of an interstellar object captured from the surface of another world. We had just photographed a visitor from beyond while standing on alien ground. Yet the real revelation was still to come. As 3I/ATLAS emerged from solar conjunction in November, panic rippled through the astronomical community. Initial observations suggested catastrophic fragmentation. Calculations predicted the nucleus had exploded into 16 separate pieces, scattering debris across millions of kilometers. The object had died. Our opportunity to study it was over, except it hadn't died. Follow-up observations revealed the truth. 3I/ATLAS survived completely intact. No fragments, no debris field, no explosion. What appeared to be disintegration was actually an intense burst of activity, a natural eruption of sublimating ice and dust that temporarily obscured the nucleus. The visitor was wounded but alive, continuing its journey outbound from the sun. But survival only deepened the mystery. The calculations seemed ironclad. The mass loss observed should have destroyed any natural nucleus. The outgassing rates measured shouldn't be sustainable. Yet here it was, intact, accelerating away from the sun as if nothing happened. How? The answer came from an unexpected source. Radio waves from South Africa. An array of radio telescopes detected something never before captured from an interstellar object. A faint signal at specific frequencies, 1,665 and 1,667 megahertz. The signature of hydroxyl radicals, the broken fragments of water molecules. But this wasn't just detection. It was definitive proof. Radio waves penetrate dust clouds that block visible light. They see through the densest comas, straight to the gas composition. And what they revealed ended the propulsion debate conclusively. 3I/ATLAS was soaking wet, venting massive quantities of water vapor as it heated. This was no dry, rocky probe, no defunct alien technology. This was ice, ancient, pristine ice from another star system, now boiling away in our sun's heat. The chemistry was unmistakable, the signal impossible to fake. 3I/ATLAS was natural. But if the spaceship theory was dead, the real mystery was just beginning, because what the chemical analysis revealed was far stranger than any artificial probe, more unsettling than any conspiracy. It revealed something fundamental about the nature of interstellar space, something that changes our understanding of every object drifting in that infinite dark. The James Webb Space Telescope turned its infrared gaze toward the outbound comet. What it detected was impossible. The carbon dioxide ratio was wrong, catastrophically wrong. In normal comets, water dominates. The CO2 to water ratio averages around 0.12, about 12% carbon dioxide to water ice. Standard, expected. Universal across every comet we've studied. In 3I/ATLAS, that ratio measured 7.6. Think about that number. This object contains nearly 60 times more carbon dioxide relative to water than any comet should. It's essentially a dry ice bomb wrapped in a thin shell of frozen water. The chemical composition is so skewed, so far outside normal parameters, that it shouldn't exist naturally. Yet here it is, real and measurable and screaming across our solar system. The explanation is terrifying. For billions of years, longer than Earth has existed, longer than the sun has burned, 3I/ATLAS drifted alone through interstellar space. And that space is not empty. It's filled with radiation. High-energy cosmic rays from exploding supernovae, from colliding neutron stars, from the violent hearts of distant galaxies. These particles, moving at nearly light speed, slam into anything in their path. When they hit ice, they don't just impact the surface. They penetrate deep, meters into the frozen structure, breaking chemical bonds at the molecular level. Over millions of years, this relentless bombardment converts simple water and carbon monoxide into carbon dioxide and complex organic compounds. It creates a processed crust, a radiation-burned shell of transformed chemistry extending 15 to 20 meters deep. 3I/ATLAS spent eons bathing in cosmic radiation. It cooks slowly in the galaxy's invisible fire. What we're seeing sublimate away isn't the pristine interior of an ancient comet. We're watching its radiation-scarred skin peel off, layer by layer, revealing the chemical violence of interstellar travel. The implications are staggering. Every object that has drifted between stars for billions of years will look like this. Chemically transformed, radiation damaged, fundamentally altered by its journey through the void. We may never see a truly pristine interstellar visitor unless we catch one extraordinarily young, or unless one breaks apart completely to expose its unaltered core. Interstellar space isn't empty. It's a cosmic oven, and everything passing through it bears the scars. But the chemical surprises weren't finished. Spectroscopic analysis revealed something else lurking in the sublimating coma. Metals, specifically iron and nickel vapor, materials that shouldn't exist in gas form around a comet. Yet there they were, spectral lines clear and unmistakable, indicating 3I/ATLAS carried metallic grains embedded in its ice. The nickel-to-iron ratio was abnormally high at first, unlike anything in our solar system's comets. Then, as the object approached the sun, that ratio began falling toward normal values. It was as if the heat was selectively vaporizing different metals at different rates, revealing layers of composition as the comet burned away. These metals unlock the final piece of the puzzle. When water ice melts inside the comet's porous structure, heated by the sun or by internal pressure building, it comes into contact with microscopic grains of iron and nickel. In the presence of these metal catalysts, water reacts with carbon compounds in Fischer-Tropsch reactions. These reactions are exothermic. They release heat. Suddenly a feedback loop ignites. Heat melts ice, which reacts with metal, releasing more heat, melting more ice. Pressure builds under the frozen crust until something ruptures. Then, violent eruption. A geyser of gas, dust, and vaporized metal explodes outward. This is cryovolcanism, ice volcanoes triggered by internal chemistry rather than external heat. This explains everything. The impossible brightness surge, the fire hose water loss at freezing distances, the metallic vapor in the coma, the surviving nucleus. 3I/ATLAS isn't just sublimating passively like a normal comet. It's exploding from within, driven by ancient chemical reactions between alien water and alien metals from another star system. The sunward jet, not a thruster, a ruptured weak spot on the sun-facing side where internal pressure found release. The non-gravitational acceleration, not propulsion, the rocket effect from asymmetric outgassing, precisely as predicted by physics. The strange colors, not camouflage, sequential sublimation of different layers, dust, then cyanide compounds, then deep volatile ices. Every anomaly has a natural explanation, but those explanations are stranger and more violent than any artificial probe theory. 3I/ATLAS is a cosmic pressure cooker, a frozen chemical bomb that has traveled for billions of years and is now detonating in slow motion as our sun's heat penetrates its radiation-scarred crust. And its journey isn't over. Right now, at this moment, the battered visitor is racing outbound from the inner solar system, heading toward one final encounter. In March 2026, it will pass within 0.35 astronomical units of Jupiter, close enough to enter the giant planet's gravitational sphere of influence. The encounter won't capture it. 3I/ATLAS is moving far too fast to be trapped, but Jupiter's immense gravity will bend its trajectory one last time, altering its path as it leaves our solar system forever. A spacecraft currently orbiting Jupiter might witness this final flyby. If it's still operational, if it's positioned correctly, if we're lucky, one last chance to study this interstellar traveler from the perspective of the outer solar system before it vanishes back into the cosmic dark. But here's what haunts astronomers. We don't know where it's going. The trajectory calculations show 3I/ATLAS will leave our solar system on a course toward the constellation Lynx. But after that, will it drift for another billion years before encountering another star? Will it fall into some distant sun and disintegrate? Or will it wander forever through the endless night between galaxies, a frozen monument to a star system long dead? What 3I/ATLAS has already taught us is profound. The space between stars is not empty. It's not peaceful. It's a radiation-blasted furnace that transforms everything passing through it over cosmic timescales. Objects traveling between star systems don't arrive pristine. They arrive scarred, altered, chemically transformed by their journey. The galaxy itself is an active environment, reshaping matter at the molecular level through processes we're only beginning to understand. This visitor survived billions of years drifting alone. It survived cosmic ray bombardment that would sterilize any biological material. It survived the crushing cold and vacuum of interstellar space. It survived a death dive around our sun at temperatures that melt lead. and now it's leaving, carrying away data about our star system back into the darkness. But it's leaving us with questions that may take decades to answer. How common are interstellar visitors? Are dozens passing through our solar system right now, too dark and distant to detect? What other chemistries exist in comets from alien star systems? And most disturbing, if 3I/ATLAS is what natural objects look like after billions of years in space, how would we recognize something artificial if it did visit us? The universe just sent us a messenger. We read its message, and the message is clear. Everything we thought we knew about interstellar space was wrong. The void between stars is not passive. It's violently active, constantly processing and transforming matter in ways that defy our Earth-based intuitions. Every object out there is being cooked, altered, scarred by its journey through the cosmic radiation bath. 3I/ATLAS isn't just a comet. It's a warning, a preview of what awaits anything that dares travel between stars, including perhaps us. If humanity ever sends probes to other star systems, they'll arrive damaged, transformed, chemically altered by billions of years of radiation exposure during the journey. This is the true nature of interstellar travel, a slow burn across cosmic time that changes everything it touches. The visitor is leaving now, fading from our telescopes, dimming as it retreats toward the cold outer reaches of the solar system. Soon it will be too faint to observe, lost among the countless background stars. And then it will cross the heliopause, the boundary where our sun's influence ends, and disappear back into the interstellar medium from which it came. But somewhere in the galaxy, another visitor is already on its way, racing toward us through the dark, carrying secrets from a star we'll never see, bearing the scars of a journey we can barely imagine. And when it arrives, we'll be watching, learning, decoding the messages written in its chemical scars. Because now we know what to look for. Now we understand the language of the void. And that language is written in carbon dioxide ratios, metallic vapors, and radiation damage that tells stories spanning billions of years. The truth was never hidden. It was just traveling at 68 kilometers per second, wrapped in a cloud of sublimating ice, waiting for us to be smart enough to read it. Now the question is, are we ready for what the next visitor will tell us? If this cosmic mystery left you breathless, if the idea of radiation-scarred messengers from alien star systems sends shivers through you, then we need you in this community. Subscribe and become part of the network tracking these interstellar visitors. Comment below, what do you think is traveling through the void right now heading our way? What other chemistries exist in comets born around alien suns? Share this with anyone who still believes space is empty and quiet, because we just proved it's neither. It's violent, transformative, and full of ancient travelers carrying secrets we're only beginning to decode. The next visitor could arrive tomorrow. Will you be watching?